Today we begin a fairly quick chapter, chapter 4, called Regression. So 4a involves us fitting what we call a least squares regression line. So what we're trying to do in this chapter is basically, if we've got a scatter plot like so, and we notice that the scatter plot suggests that the data is linearly related, then what we want to do is fit a line to it. Now, you've been seeing in class or on the videos that I've been sort of drawing what I call a line of best fit by eye. Well, what we're going to do is use a more formal approach, which is to use the least squares regression method. So it's assumed that if we use this method that there are no clear outliers and that the variables are linearly related. Okay, now if the variables are not linearly related, it will still attempt to fit one of these lines to it, but it just won't work properly. So what the idea behind the approach is, it reduces the vertical distance between the line of best fit and each point. So basically what you're trying to do is reduce this distance. So if we've got here, we've got a point here, we've got a point here, we've got a point here, a point here, and a point here. And here is the regression line, and what we're basically trying to do is minimize these distances from the line, i.e. get a line of best fit. So when we do this, we're attempting to minimize the sum of the squares of the vertical distance. Okay, so this here, this distance, this distance, this distance, and this distance, and this distance, if we added the square of all of them together, it'd be the smallest possible value that's obtainable. Now, you don't really need to know how that actually happens. The calculator will fit this line for us, and you just got to have faith in the calculator that what it will do is minimize the sum of the squares of the vertical distance. Now, another thing that we'll focus on a little bit more later on is what we call the residual. Okay, so the vertical distance the point is from the line is what we call the residual. So I'll just get out the highlighter here and note that this part here, where's my pen? Yeah, so if I look at this part here, this vertical distance is the residual, okay? And the residual tells us how far away from the line the point was. Okay, so this one, next one here, I've lost my mouse, there it is there. Okay, so that's gonna have a smaller residual than this one. This one probably has a residual in the middle because it's medium distance away. This one looks the furthest away from the line, this one here. This one only looks like a small distance away from the line. So the vertical distance is called the residual, i.e. how far away from the line of best fit is the actual point. So here it is more formally, the difference between the actual value and the predicted value. So this regression line is what the line predicts the value to be, and the actual value is this distance away. Okay, so the plotted points represent the actual value, and substituting the same explanatory variable or this x value into the least squares regression line predicts the value of the RV. So that's how we get the prediction. We'll do heaps more work on residuals when we hit it down the track. So very quickly we've hit the end of the theory there. So the work is going to be 4a questions 1, 2, 3 from memory, fairly quick one. Alright, so you might then wonder, how do we get the equation of the least squares line? Now what we'll do is we'll cover two methods of doing it. So when a least squares line equation is found, the equations must be written in terms of the variables rather than x and y. I'll go on to explain in a bit. So what we can do is find the equation algebraically, and we're going to write them in the form y equals a plus bx. You can also write them in y equals ax plus b form. Doesn't matter if you put the gradient and the y-intercept in that order, but generally speaking in further maths we write it in this way. Now the a is what we call the y-intercept, and the b value, so let's point to what it is. There's the y-intercept, and the gradient is the b value there. Now to find the gradient, one of the methods that we can use, this is the algebraic method, is multiply Pearson's correlation coefficient by the standard deviation of the y values over the standard deviation of the x values. That sounds complicated. And to find the a value, what you can do is remove b times the value of the mean of the x values from the mean of the y values. All right, again, this sounds like a really convoluted process, but I'll show you how it works in an exam situation. So these are all the definitions here. So R is the correlation coefficient, SY, standard deviation of Y, etc. So all of it's explained here. Now, how do you use this idea in an exam? Well, once every while, this particular exam question comes up. So for a set of bivariate data that involves the variables X and Y, we've got these 5 values. So somehow we've got all of these 5 values here. So given the information above, the least squares regression line predicting Y from X is closest to. Alright, so the way we're going to do it is, let's have a look and see if we can find something unique straight away. Alright, so I think, let's go ahead and see if we can find the gradient. Because we've got one gradient here, that's a different gradient, that's a different gradient, that's a different gradient, and that's a different gradient. Whereas we've got the same y-intercept, same y-intercept, same y-intercept, same y-intercept, and different one. So what we'll do is we'll go ahead and find the gradient. So I'm going to go up here and find out my method of finding the gradient. So B is the gradient, so this is what I'm going to do. So I've got R, which is negative 0.47, multiplied by the standard deviation of Y, which is 0.85, over the standard deviation of X, which is 1.8. Alright, so now what you would do is go over to your calculator and simply type that in. So we've got negative, not ants, I think it's a control, and that is it. Oh, there it is there. Okay, so negative 0.47 multiplied by control divide 0.85 over 1.8. It'll automatically approximate for us because there's decimals in the question. Negative 0.22, that doesn't sound right. Standard deviation of X. So I know that that's wrong. I'm going to leave this in. That's fine. What I've done here is I've used the mean of X. Okay, so let's correct our notes there and remove that part there and note that I should have used 1.2. Okay, so the way we'll do it is going back to the calculator. We'll hit enter now to copy that down. And instead of using 1.8, we're going to use 1.2. Okay, negative 0.33. So it's this one here, negative 0.33. So the answer has to be C. Lucky they didn't use this as a distractor or put that value in and pop that in as a distractor. But again, just check the formula carefully and make sure you're using the right thing in the right place. What I'll do, I'll also just confirm that the y-intercept is 7.8 by working that out using the formula as well. So this is the formula to find the y-intercept. So it's A equals y bar, or y, the mean of the y values, which is 7.2, take away our b value, negative 0.33 ... times the x value, x bar value, which is 1.8. So if I've done this correctly, when I jump on the calculator now, it should be, so 7.2, take away, open your brackets. Now this here is, that's the previous value here. How do I use that? I'm going to hit Control and subtract, and that's going to fill in this thing called ANS. Now ANS refers to whatever was stored in this slot here. So that's negative 0.33, and we're just going to refer to the exact answer. So we multiply ANS by 1.8. Alrighty, and we should get 7.78, is it? What do we get? 7.79, but it's closest to, and I presume it's closest to because they might have used the rounded version of that. Either way, that is certainly our answer there. So that's how you use those particular formulas here to get the regression line. Okay, so this here is the line of best fit for this statistical data here. Doesn't happen often, but this question does come up. So you want to have this in your notes ready to go for when it does, if it does come up this year. All right, Here's the more typical question. So the heights and weights of a group of people were recorded and the results are in the table below. Which variable is the explanatory variable? So again, this is really important to note now. Okay, so this is important. Because when we fit a regression line, I cannot get the EV and the RV around the wrong way. It's got to be in the right order. Okay, so order of EV and RV is important. Now, the R value is not important whether you get the EV or the RV right, okay? But the line of best fit or the regression line is important. Okay, so what I'll do is pop the data in. So I'm going to go Control and Doc and chuck in a list and spreadsheet. This one's my weights. This one's my heights. Pause it here so that you don't have to watch me bang in the data. Okay, so I've got my data typed in. Oh, by the way, the explanatory variable is height. So EV is height in this case. All right, and what we're doing is we're determining the equation of the least squares line, but we're not going to use this algebraic method here. What we're going to use is the calculator, noting that they want it rounded to 3 significant figures. Okay, so what we'll do is go Control and Doc, and we'll pop in a data and statistics. Right, so tab around and make sure that you get your height as the EV and weight as the RV. Excuse me. All right, so now that we've got our scatter plot, we've confirmed its roughly linear relationship and there's no outliers, so let's fit a regression line. So we're going to go Menu, Analyze, Regression, and Show Linear. Okay, so let's go through those steps. So we're going to hit, where's my pen gone? So it's Menu, 4, six, and I'm going to use 2. Menu 4, 6. 2. Okay, so what you'll see is that they've fitted this line here, this line of best fit, and this line of best fit is in fact the least squares line. And we can see here also that they've written the equation of that line in on the graph here, or next to the graph. So that's the one that we're interested in, determining the equation of the least squares line. State values correct to 3 significant figures. So the first thing I'm going to do is write down y equals. All right, now 3 significant figures means that I just move from left to right, finding the first non-zero value, and then I go 1, 2, 3. So it's negative 66.8. 8 means that this 8 needs to get rounded up, so that's 66.9 plus 0, non-zero, 1, 2, 3. This is 9, 7 next to it, so this goes up by 1, so it's 860. 0.860x, and that's our regression line. Now, the thing to note with this is that when we do this, it's important that we put the names of the variables in our equation. So it's got to get driven by context. Okay, so when you have to do this in the SAC or the exam, that's not going to be good enough for your examiners. So what we're going to do is replace the y value and the x value with our EV and RV. So remember that this is the RV and this is the EV. Right, so the explanatory variable here is height, the response variable is weight. So we're going to write our formula as weight equals negative 66.9 plus 0.860 multiplied by the height. Right, so really important to remember that, okay, that we write our responses in context. There we are. So that is really important, and that is really, really important. Okay, this exercise is a really good exercise also for practicing your rounding skills and your rounding to the correct number of what we call significant figures. Now I'm going to show you something very quickly. So instead of I'm going to put the variables the wrong way around. So I'm going to put the weight there, and that means that the height is there. And what you'll notice straight away is that the regression line or the equation for the regression line has changed. Okay, and that would be the incorrect equation. So the correct equation has the EV here, which is height, which explains the weight. Okay, again, note that the R value will be the same with the variables either way around, but the equation is different. Okay, so that's an important thing to note. Other than that, I'd say not much else I can tell you. So go ahead and do work 4B. From 4B, and there's a fair few questions there, just getting your practicing skills up to scratch. Oh, actually, I will show you one more thing. Right, so what we'll do is we'll go Control and click left, and what that will do is take us back to this sheet here. Just another way to get the equation. So what we'll do is we'll go Menu, 4, 1, 4. Okay, and this asks for the x values, which is the height is the explanatory variable, and weight is the response variable. And it'll insert it in column, no, not column B, we want it in column C. And we hit OK, and this will give you those figures separately. So this will give you the A value separately, the B value separately. Why am I telling you to do it this way? Well, you don't have to. The book doesn't explain it this way, but this does give you the R and the R squared value. So if you're basically getting the R value first and then needing the equation, you might want to just go straight in and copy it from here rather than going across to something like this and getting it to do it this way. Anyway, just giving you some options.